reflection, which is bouncing back off a shiny surface like a mirror. We've done refraction, which is when the ray of light goes into another medium, so it could be glass, plastic, water, and it bends, changes direction because the speed changes. So we're going to look at a sort of special occurrence now, which is called total internal reflection. Okay, and it happens at a certain angle. So you guys are going to do this experiment. So you can see we're going to use our ray boxes again. So you should have your kits at the side. And we're going to be using this semicircular glass block. And before I show you what you're going to do, I want you to draw in a few more arrows. I'm afraid there's quite a lot of arrows to be drawn in this topic. So we've got a diagram here. So what we're going to be doing is we're going to be shining light in the flat surface of the semicircular block. So it's through the semicircular block. So at that surface, we will get two things happening. We will get a reflected ray, and we'll also, when it goes back from the perspex into air, we'll also get a refracted ray. That's our angle of incidence, I. That's our angle of reflection, which I'm going to call, let's say just B, because they're both R's. And that's our angle of refraction, which I'm going to call C. So we've got angle of incidence, angle of reflection, and an angle of refraction. Because you're going to be measuring both the angle of refraction and the angle of reflection in this experiment. So it's a little bit more complicated than you have done in the past. So angle of refraction is your B, angle of incidence is your I, and angle, oh no, sorry, done that wrong, whoops. Angle of refraction is C, and angle of reflection is B. Okay. And I'll show you what you're doing in a second, but what you're going to be doing is you're going to be shining light in at different angles of incidence, like when you did with the mirror. And you're going to be observing the reflected ray and the refracted ray as you do this. Okay, so I'll just leave that up for a little bit longer, and then I'll show you on the board what we're going to be doing. Okay. Right, so I have given you some pre-drawn angles again, like I did when you did the mirror one. And again, the photocopying is not brilliant. So what you're going to be doing is you need your single slits again, and I've also drawn around the block for you. So just put a block where my block's slightly bigger than my drawing, but it doesn't really matter. I'm going to start off by shining it in to hit the normal. So remember, it has to hit the normal through your glass block at the 10 degrees. Okay, and you should see very faint. You can't really see very well. You should see reflected ray. I can see it here, but you can't see it. It's not showing up on the board very well. A reflected ray and a refracted ray. So you should be getting a reflected ray and a refracted ray. You draw in your reflected ray and your refracted ray and measure their angles. Okay. So again, my reflected ray here is very faint, but it is there. And you're going to move it round until eventually your refracted ray will disappear. You see, there we've got a refracted ray, and eventually at some point you will see the refracted ray disappears. Okay, that's fine, keep on going, you'll still have a refracted in your reflected ray and your refracted ray and measure their angles, remember they're always from the normal. Do it again for 20, do it again for 30, do it again for 40, 50 and 60 degrees. Okay. And once you've done that, you're going to be filling in your table as you go along. So you should know now that the angle of reflection is going to be the same as the angle of incidence. So it should, if you're not getting that, you've done something wrong. Then what I'd like you to do just at the bottom of the table is write down the angle of incidence where the refracted ray disappears is. Okay, so what I want you to do is find the exact angle where that refracted ray disappears and just write that down underneath here. After you've filled in the table. So you will find probably that you won't have an angle of refraction at 50 and 60 degrees, and that's fine. You will have an angle of reflection. Any questions? Right, as usual, a couple of minutes to get your ray box set up, and then I'll turn the lights out. Again, I'm sorry the blind's not appeared for one side.